In this video, let's take a look at another type of centers of triangles called the circumcenter. The circumcenter is made up of the perpendicular bisectors of the sides of a triangle, and they intersect at a common point that we call the circumcenter. So let's start filling in our notes. The perpendicular bisectors of the sides of a triangle intersect at a point we call the circumcenter. The circumcenter is always equidistant from the vertices of the triangle. And then let's use the diagram to the left to answer the following questions. So list the perpendicular bisectors. So that would be PE, PF, and PD. Let's write those down. PE, PF, and PD are the perpendicular bisectors. Name the circumcenter, so that's just the point they have where they all intersect, which is just P. And then list all congruent segments. So some of the congruent segments are already labeled for us in the picture. We have AD is congruent to BD. We have BE is congruent to EC. And we have AF is congruent to FC. And as we wrote in our notes, let's also label that the circumcenter is equidistant to the vertices. So PB, PC, and PA. Those would all three be congruent as well. So I'm going to add 4 tick marks to those segments, and we'll write those out. So let's say PA is congruent to PB, which is also congruent to PC. Okay, so let's use those properties of circumcenter to figure out 3 examples. If Z is the circumcenter of triangle TUV, find each missing measure. So they asked us for TU, which is the total of this side, and we're given that half of it, because we know that this point right here is the perpendicular bisector, so it breaks it into 2 equal segments. They would both equal 19. And so the total for TU would be to add the 19 plus the 19 and get 38. VY is half of this side over here that they've told us is 34. So we could say 34, here's the perpendicular bisector, so these segments are congruent. So half of 34 would give us 17 for VY. UZ is the segment that is connecting the circumcenter to the vertex U, and we're given that one of those is equal to 21. VZ is given as 21. So that means the other two that go from the circumcenter to the vertex are also equal to 21. And now we get to WV, where we have to do a little bit of extra work. We see that we have a leg and a hypotenuse of this right triangle, because that's a perpendicular bisector. So we can find the missing side using our Pythagorean theorem. So let's say 15 squared plus WV squared equals 21 squared. We can subtract 15 squared from both sides, so we get WV squared equals 21 squared minus 15 squared, and then we can pull up our calculator and calculate, and then we'll take the square root. So let's type in 21 squared minus 15 squared is 216. Whoop, let me write that correctly. So 216. Then when we take the square root of both sides, we get 14.7. So WV equals 14.7. So that would give us this segment and also the one right beside it, because those would be congruent. All right, so let's put 14.7 for WV. And then they asked us for TV, which we just figured out. Both of those segments are 14.7. So if we just multiply 14.7 times 2 or add 2 of them together, either way, you get the same thing. So we get 29.4 for TV. All right, let's look at another example. Clear out my calculator. If H is the circumcenter of triangle BCD, find each missing measure. All right, let's start with some that we know by looking at the figure. So they said to find GD. We are given that one of the segments going from the vertex to the circumcenter is 13. So therefore, all three of those would equal 13. So actually, they're asking for GD. That's HD. So let's see. Let's find GD would actually be half of this side over here, which they gave us was 24. So GD would just be 12. Half of 24 is just 12. All right, BC, so let me make sure I get the right side this time. BC is this whole side over here, and they gave us half of it, which is 7. So we know the other half is 7. And so BC being the total would be 14. 7 plus 7, or 7 times 2. Then they asked for EH. So EH is part of a little right triangle that we know two sides of, so we can figure out the missing side. So we're missing that leg EH, but we're given one leg is 7 and the hypotenuse is 13. So we can say 7 squared plus EH squared equals 13 squared. And then we can just use our calculator to help figure that out. So 13 squared minus 7 squared. And then we'll take the square root. All right, so let's type in 13 squared minus 7 squared, which would be 120. And then when we take the square root of both sides, we get 10.95 for EH. All right, now we need to find FD. So FD is the side of this triangle over here. And we don't have CF, so we don't know what it would be equal in an easy kind of way. But we do know that one I started shading in the beginning, HD would be 13 because BH is 13, and those are all congruent, those ones I shaded in purple. And then we end up with that little right triangle over there, and we have a leg, and we have the hypotenuse, so we can figure out the missing leg using the Pythagorean theorem again. So 3 squared plus FD squared equals 13 squared would be the way we could set that up. I like to go ahead and subtract it and then just type all that straight in the calculator, and then I'll take the square root. So 13 squared minus 3 squared gives us 160. And then we just have to take the square root of both sides, which is 12.6. I'm just going to round to the nearest tenth. 12.6. So FD was 12.6. And then they want to know CD. So now we can figure that out pretty quick, because if this one is 12.6 for FD, and then F is the point where it's bisected, then we know that these two segments are both 12.6. So 12.6 plus 12.6 would be 25.2. All right, one more example. Example 3 says the towns of Adamsville, Brooksville, and Cartersville want to build a library that is equidistant from the 3 towns. What is the name of the center of the triangle they should use? So if you're trying to build a library in the middle of these 3 towns, the best option is the circumcenter, because it's equidistant from the vertices of the triangle. So that would be the best center of a triangle to use. So let's write circumcenter, because it would be equidistant from the vertices. Or let's say the 3 towns, because the towns are our vertices in this case. All right, so those are the notes for circumcenter.